Today we're going to talk about postulates and formulas to measure segments. So the first word we need to be familiar with is congruent and what it means for something to be congruent. Congruent means it's exactly the same as. It's like saying they're equal to, but we use congruent a lot more in geometry because it means it's the exact same size and shape. So we would say, in this case, AB and CD are the same, so segment AB is congruent to segment CD. We're going to use this graph to talk about congruent segments. So pause the video right now and graph segment JK and LM. Okay, now once you've graphed your two segments, segment JK and LM, we want to look at them to see if they're congruent. So I can look here and count the spaces, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And remember, we count spaces, not lines. And we see that JK and LM are the exact same length, and they're both line segments, so they are congruent. So we would write the statement that segment JK is congruent to segment LM. Now we're going to talk about the segment addition postulate. We have a segment here with points A, B, and C, and they're collinear. And so what the segment addition postulate says is if you take the length of AB and add it to the length of BC, that gives you the length of AC. It's pretty logical. So what we're going to do is we're going to use that to find the length of DF. So we know that DE plus EF equals DF. So we're going to substitute the length of DE in and substitute the length of EF in. And then we get that DF is equal to 58. We can also use the same idea here. We know that FG plus GH equals FH. And this time we know FG is 21. And we know FH is 36. So we know that GH is equal to 15. So we're going to use that same idea again, and I always like to write that equation. And so we want to find xz, so we know xy plus yz, sorry, that's a yz, equals xz. And then I'm going to substitute in what I know, which is the lengths. And I get that 73 is the length of xz. So again, I always like to start by writing that first equation. Now, in the diagram, if we say that this is 30, the length of WY, can we use a segment addition postulate to find this length? And the answer to that is no, because WY and Z are non-collinear. And the segment addition postulate only works for collinear points. Now we're going to do the same thing, except we have some variables thrown in the mix. So we're still going to start by writing the equation AN plus NB equals AB. Now I'm going to substitute in what I know, and that's that AN is 2x minus 6 plus NB is x plus 7. And that's going to give us the length of AB. Okay, and I'm going to make sure I put that segment notation on there. It's hard to do that typing sometimes, but if I'm writing, I really try to do that. So then we have 3x plus 1 equals AB. And now we know AB is 25. So we have 3x plus 1 equals 25. So I can subtract 1 and get 3x equals 24. So x is equal to 8. Now we are asked to do the second part here. Find the length of AN and NB. So I can take this 8 and plug it back into those guys up here for x. So I know that an equals 2x minus 6. So an is equal to 2 times 8, which is 16, minus 6, which is 10. And I know that nb is x plus 7, so 8 plus 7 is 15. And this is, again, the segment addition postulate. Okay, I'm going to give you a minute, and I would like you to try to answer these questions on your own. So pause for a minute, and then when you're done answering A, B, and C on your own, look at my answers and see if yours match. Okay, look at your diagram. It should look something like mine. And then you should have written the equation Lm plus Mn equals Ln. And then plugged in what Lm and Mn were. And then 42 for Ln. Solved your equation, got an x equals 10. And then you can plug that back in, and 2 times 10 plus 8 will give you the length of Lm, which is 28. And 10 plus 4 is 14, which is Mn. Is your solution reasonable? Your answer to that should be yes, because when I add the two segments together, they give me the length of the entire segment Ln. Okay, now we're going to switch gears and we're going to look at midpoints and segment bisectors. The midpoint is the point that divides a segment into two congruent segments, so the middle point. And a bisector does the same thing, but with a line, okay? And so this is a segment bisector because it's a line that bisects AB. So we say that CD bisects segment AB, and so we know that these two pieces are equal. So if this is the midpoint here, if M is the midpoint, then we know that these two sides are the same. So we're going to set those two equal to each other. So we have 4x. Actually, let's take it back a second. We want to first write our equation that Vm is equal to Mw. So we know that we're plugging in 4x minus 1 for Vm and 3x plus 3 for Mw. We can then solve that equation, and we get that x equals 4. Now the same thing goes here. If this line N is the bisector, the line N is the bisector, that means that this is the midpoint and it's cut directly in half. So we know that Rm is equal to Ms, and so 4x plus 3 equals 6x minus 12. We can then solve that equation. And I'm going to come over this way, and I get that x is equal to 7.5. And then it asks us for the length of RS, which is the entire length. So I can plug it in and figure out half, or I can do one at a time. What I'm going to do is I'm going to just look at them together. So it's 10x minus 9 if we add these two together. So 4x plus 6x is 10x, and 3 minus 12 is negative 9. And so if I plug in 7.5 for my x, and so I get 75 minus 9, so I know that it's 66, and that's the length of RS. Now how could we find the length of this segment? Again, we're switching gears. I'm going to give you a big hint. This guy here, hopefully you've seen this before, it's a right triangle, and we're going to use the idea of right triangles. And we're going to do the distance formula. So really what the distance formula does is it solves for the length of the hypotenuse for you in the distance formula. So remember, this guy here, the longest side of a right triangle, is called the hypotenuse. Okay, and that's where this distance formula comes from, is the Pythagorean theorem. So if we have these two points here, we're going to use the distance formula. I always like to start by writing it out. And then I plug in. So my second x, we're going to start there, that's -4, minus my first x, and my second y, which is here, 7 minus my first y, here, and then I'm going to take the square root of the whole thing, so I'm going to simplify. So subtract the negative turns into plus, so we have -2 squared plus turns into 12 squared. And then I have the square root of 4 plus 144, which gives us the square root of 148, which is our most accurate answer. I'm going to ask you to try and figure out what it would be and plug that into your calculator. And so our approximate answer would be 12.17, and I'm rounding to the nearest hundredth. It was 1.165, and so I round that 6 up to a 7. Okay, so we can use the same idea of finding the midpoint, the middle point of a segment on the graph. And so we want to find about where the middle is. It's going to be around here somewhere, but we have a formula that'll do that for us. And really what we're doing is we're finding the average of the x's, so adding them together and dividing by 2, and then the average of the y's, adding them together and dividing by 2 to find the midpoint. So we're going to use the same 2 points of CD and do the midpoint formula. So I'm going to write it out. And then I'm going to plug in my numbers from my points. So my first x plus my second x divided by 2. And then I'm also going to do my first y, which is -5. Once I have my pen, I will. So -5 plus 7 divided by 2. And this is a point. That's why we're writing it like this. It's a midpoint. So then I have -6 divided by 2, comma, 2 divided by 2. So my midpoint is -3, comma, 1. That is the midpoint of that segment. So if we graphed these 2 points, the middle of those 2 points would be that guy right there. So between C and D, exactly halfway is -3, 1. So now I'm going to pause this, try to find the midpoint in the distance formula, and then come back and check and see if your answers are correct. Okay, now once I've plugged in the points 9, -14, and 3, 4 into the distance formula, I got the square root of 360, which gives me about 18.97, and a midpoint of 6, -5. Please let me know if you have questions on either one of those. And then go ahead and move on to your big ideas homework.